So today we're going to look at applications of logarithms. So let's look at our first question. If one earthquake has a magnitude of 4.2 on the Richter scale and another earthquake has a magnitude of 6.7, compare intensities of the two earthquakes. All right, so first thing we need to do is figure out what this Richter scale is. This Richter scale and these magnitudes, how that's related. So if we just scroll over to the right, we have our Richter formula. So this is m equals log of I over I0. So here m is our Richter number, I is the intensity of an earthquake being measured, and I sub 0 is intensity of a reference earthquake. All right, so with this formula, let's go back to our question and see if we can relate any information from the question to our formula. So we have one earthquake that has a magnitude of 4.2 on the Richter scale. So this is probably our M. Sorry, our M is 4.2. So this earthquake, we'll call it earthquake 1, has some intensity I1, and we're comparing that to our reference earthquake with intensity I0. So that's earthquake 1. So I don't know, we'll call that M1, or Richter number 1. Our second earthquake has a magnitude, we'll call that magnitude M2, has a magnitude value of 6.7, and has an intensity of I2. And we're going to compare that intensity to our reference earthquake with magnitude I0. Okay, so now they're asking us to compare intensities of the two earthquakes. Okay, so first thing we can do is, since we have to compare I1 and I2, is try and remove this log. So we want to try and isolate for I1 and I2. So remember, the log is the inverse of the exponential function, and if we don't have a base here by our log, then that means we assume the base is 10. So this first equation or relationship, if we use the exponential function, what do we get? We end up with 10 to the power 4.2 equals I1 over I0. So we've just removed our log. Our second relationship for our second earthquake, we have 10 to the power 6.7 equals I2 over I0. Okay, let's scroll over to the right since we seem to be going in that direction. Okay, so we can solve for I1. So what we have is I1 actually equals 10 to the power 4.2 times I0, intensity of a reference earthquake. Similarly, for the second earthquake, we have 10 to the power 6.7 times I0 equals I2. So now we want to compare I1 and I2. So we're going to look at the ratio, let's say of I1. So we're going to combine these two. We're going to look at the ratio of I1 to I2. And what do we get? We get 10 to the power 4.2 times I0 over 10 to the power 6.7 times I0. Our I0s cancel out. And we're left with, okay, 10 to the power 4.2 over 10 to the power 6.7. We're going to use our properties of exponents, and we have 10 to the power 4.2 minus 6.7. And what does this equal? This equals 10 to the power negative 2.5, or 1 over 10 to the power 2.5. So here we've compared our intensities, or so we have therefore, let's see, how can we write this? I2 equals 10 to the power 2.5 times the intensity of I1. Good, so we've compared the intensity of the first earthquake with the intensity of the second earthquake. Good. That's one application of the logarithm function. Let's look at the second one. So find the hydrogen ion concentration of milk, which has a pH of 5.75. So I'm going to scroll over to the right. We're going to look at the pH scale to measure acidity of liquids. So this pH scale has this nice relationship. So the pH of whatever we're measuring or equals negative log of H positive. So this symbol here represents the concentration of the hydrogen ions in moles per liter. Okay, and then they just tell us as reference for distilled water, the hydrogen ion concentration is 10 to the power negative 7 moles per liter. Just some information. Okay. What we're really interested in is this formula right here. So let's try and apply that to our problem. So we're asked to find the hydrogen ion concentration of milk. So we're asked to find this value for milk. Let's put a little m for milk. And we know that milk has a pH of 5.7. So we know 5.75 equals log of this hydrogen ion concentration. So we need to solve for this. So again, we can use the inverse or convert this to an exponential. So our base is 10. We're going to raise 10 to the power 5.75, and that's going to give us our hydrogen ion concentration. Oh, did we forget a negative? Let's have a look. Yes, we did. Always good to check your work. So we got our negative there. Okay. All right, so let's redo that. It's actually not too much of an error. So let's multiply both sides by, or divide both sides by -1. We have negative 5.75 equals log of our hydrogen ion concentration of milk. Again, we're going to use the inverse. We get 10 to the power 5.75 equals this hydrogen ion concentration of milk. Good. All right, so next question. So here we're looking at sound. So George's dog's bark is 1,000 times more intense than a hamster's squeak. How loud is George's dog? Interesting. Okay, let's scroll over to the right again. And here we're comparing sounds. So we have this nice formula that compares sound. So L is our sound, or loudness of our sound, equals 10 times log of I over I0. So what is I? I is the intensity of sound being measured. I0 is intensity of sound at threshold of hearing. And L is loudness measured in decibels. Okay. All right, so now let's take this formula and see if we can plug in information from our question. So what are we given? We're told that George's dog's bark is 1,000 times more intense than a hamster's squeak. Okay, so let's let I0 equal intensity of a hamster's squeak. Okay. Intensity of a hamster's squeak. All right, and I equals intensity of dog's bark. All right, and we're told that the dog's bark is 1,000 times more intense than the hamster's squeak. So I actually equals 1,000 times I0. So now we're asked to find how loud George's dog is. So this is where we use our sound formula. So we're looking for L. So L equals 10 times log of I over I0. Let's plug in what we know about I and I0 regarding our dog and hamster. So we know that the intensity of our dog's bark is 1,000 times that of the squeak of a hamster. So 1,000 times I0. So this means we can cancel out our I0s and we're left with, let's scroll over to the right, L equals 10 times log of 1,000. So that's not so bad. So log of 1,000, 1,000 can be written as 10 to the power 3. And remember, when we don't have a base with our log, that means a base is 10. Let's use some properties of logs now. And we have a 3 in the exponent, so we can bring that 3 down. And what do we get? We get 3 times, let's write it like this, 3 times 10 times log 10, again, base 10. So log, so let's just put it up here. So recall log base b of b equals 1. So log base 10 of 10, this equals 1. So we're left with 3 times 10, which is 30. So the loudness, if we go back to our question, the loudness of George's dog is 30 decibels. Therefore, George's dog, did I spell George correctly? No, I did not. All right, George's dog's bark. How should we word this? Is 30, I think decibels is dB. Is that the correct? I believe so. It's 30 decibels. Good. So you've seen 3 applications of the logarithm function. Let's go back up. One was for earthquakes with the Richter scale. One was for finding the hydrogen ion concentration or pH of something. And the last one was for sound. So this brings us to the end of our video today. If you have any questions, send us an email at info@raisemymarks.com or give us a call day or evening, and we'll be happy to help you. Thank you for watching. We look forward to seeing you again.